Hi, let's continue our discussion on implementing logistic regression. By the end of this video, you will be able to plot AUC-ROC curve and study and make inferences from the coefficient plot. Now, let's move forward to the ROC curve. As we have discussed in the previous topic, ROC curve has been widely used to measure performance of models in data science. Let's see how it is made. We will use the same dataset, churn prediction simple. Now, we will again import the ROC curve function from the sklearn metrics module. We call this function using the actual labels ytrain and the predicted probabilities. Note that we are passing the probabilities of class 1. This function is similar to the precision recall curve function, which returns a list of FPR and TPR values for different values of the probability thresholds. If you are not sure what FPR and TPR are, we have already discussed them in our previous videos. I would suggest you to kindly revisit the videos again before we proceed further. Now, we will plot the ROC curve using the matplotlib. For this, we will simply pass the FPR values on the x-axis and the TPR values on the y-axis as shown in the line 3 of code. In line 4, we are plotting the ROC line with AUC equal to 0.5. We are doing this by simply plotting the line y equal to x. In the last line, we simply print the area under the ROC curve using the ROC AUC score function. On running this cell, we get a plot which looks like the model is performing okay. Still, the model seems to be over the baseline of 0.5. The AUC of the ROC is 0.73. Most of the real world scenarios are like this, where minimum or no feature engineering will only give average results. Now comes the last part, interpreting the coefficients obtained after the logistic regression. The coefficients tell us how much the model is depending upon each variable for generating predictions. For interpreting coefficients, we start by extracting the coefficients of the independent variables assigned by the classifier using the model.coef_attribute. Also, we will extract the name of the columns with the help of the x.columns, where x is the set of independent variables. Now, we will arrange these two lists into a data frame called coefplot and then sort this plot on the basis of the coefficients. Now we simply use the horizontal bar to plot the coefficients with respect to their corresponding independent variables. On plotting the coefficient plot, we can clearly see the factors that determine the probability of the target variable in our classifier. Remember that we have only performed minimum viable feature engineering. Therefore, the results may differ from the real information that we can extract from a better model. According to this coefficient plot, average monthly balance previous quarter, current month debit and previous month debit are the factors which worked in favor of class 1. That is, higher these values, higher the chances that the customer would churn, which makes sense also, as the customer makes more debits to his accounts, he is less likely to stay as he is withdrawing money from the bank account. On the other hand, variables like current balance, current month credit are the factors that were indicators that customers are less likely to churn, but these are only coefficients based on a crude model. Properly pinning down significance will require more analysis and feature engineering. So with this, we wrap up Module 7 on logistic regression. While several concepts in this module such as data preprocessing, implementation were common or similar to linear regression, the concepts on evaluation metrics were new and you should thoroughly understand them before moving further. Don't let confusion metric confuse you. Also, we have given the original dataset of this problem as a module assignment for you to do pre-processing and feature engineering on, and then rebuild the logistic regression model and see if you can do better than the quick and dirty model we built here. All the best for your module test. See you in the next module.